So we're on 8.4. So this is looking at, so we've been talking about sine graphs, how they're like waves, right? And they cycle, that would be a period length, and then they repeat. Equations, and we've been talking about cos ones too, right? Cos and sine graphs make the same kind of wave cycle, except cos starts at your amp and comes down, and sine starts at 0 and 0 and cycles. Okay, so we'll refresh. This is what cos would look like. And this is what sine is. Okay, so the equations that go with them are right here. They're really important, and they tell us all the pieces that go with it. So we have sine, we have a sine b, x minus c plus b. Okay, and each of those things means something. So a is our amplitude. Okay, so now we're getting into if you move the picture left or right or up or down, like you can be shifting it. Okay, so A is the amp, so that tells you how high or low the picture is going. Okay, B is our period length. So we always said our period length was like one cycle. So it's 2 pi divided by whatever our B value is. Okay, so you take 2 pi and you divide whatever your B is, and that's your period length. Okay, that's supposed to be x minus c. C is a horizontal translation. So if it's negative, like how it's minus c, if it's negative, that really means it's moving to the right. It's moving over to the right. And if c is positive, it means it's moving over to the left. Okay, so it's actually the opposite. Negative is moving backwards, but it's negative, it's moving your points. So that would be like your x points, right? It's moving to the right, and if it's positive, it's moving to the left. And B is the only other piece, and it's a vertical translation, meaning it's moving up or down. Okay, so if it's positive, it moves up, and if it's negative, it moves down. Okay, so that's what all the equation means. And it means the same if it was cos too. So if this was cos right here, all these pieces still mean the same. So we don't need to write it again. Okay, so I said the period length is either 360 divided by b or 2 pi divided by p. Or b, sorry, because 360 and 2 pi mean the same thing. It's a full cycle. The value of c indicates the horizontal translation, so that's what I said. The equation of the midline, y equals b. So remember we said what the midline was. You take your max value, you add your min, and you divide them to 8.3. And this is what the graphs look like, right? And this could be them shifting. This is the midline. And okay, so we'll do an example. Okay, so example 1. Example 1 says, consider the function, so it's y equals 2 cos 4x plus 1. So it says, describe the graph of the function by stating the amp, the equation of the midline, the range, and the period, as well as the relevant horizontal translation. Okay, so if we want to say the amp, what is it? 2. Yeah, because it's whatever's in front of cos. The equation of the midline, so they were saying if you take D, and you subtract whatever A is, and it's D plus A. And then that'll give our maximum midpoints. So D is what? 1? So if we go D minus our amp, you get minus 1. If you go, this is D minus A. This is D plus A. And you get 1 plus 2 equals 3. So then our picture should be, that's our minimum. The lowest it goes is minus 1. And then the highest it goes is this is the min, and this is the max. So our picture goes to 3 and down to minus 1. And then our range and our period, as well as the horizontal translation. Okay, so our period is, and since we're in degrees here, we probably want us to answer in degrees. Instead of 2 pi, we'll go 360 divided by whatever the x, that's 4. Then that should be 90. Period length. And then do we have anything in a bracket so that we're moving left and right? Correct? No. So all we have is a plus 1, so that means we're moving up or down. So you could say no horizontal asymptote. Or not asymptote, sorry. Because there's no bracket. And then the vertical translation is positive, so that means we're moving up 1. That's right at the end. Okay, so the same we can do for, and you can enter this in the graphic calculator. That's what it's for graph it using technology. You would enter it in the y equals. And example 2 is exactly the same. I don't know if we need to talk about all the pieces, but our amp is 3. Our period length is going to be 2 pi divided by 2. Right there. So our period length would be pi, or you could say 180. And then this is in brackets. You see this? It's like an x minus 45. So that means you're moving left or right. So if you go negative, you're moving to the right 45 degrees. And that's a horizontal translation. And since this is in degrees, we should probably do the period like degrees. So this would be 180. That's the same thing as pi. Okay, and if we were, I guess we didn't talk about the range in the other one. The range is always how high and how low it goes, right? So, in this one, our amp is 3, so that means we're going as high as 3 and as low as 3. So you'd say y has to be greater than or equal to minus 3, but less than or equal to plus 3. So it's going to look like. The midline is the middle, and the amp and the range is like how high it goes. So it's more like the max. Like in this first one, our max was 3 and our min was minus 1, so you'd say y has to be greater than minus 1 but less than. Okay, and then our third example says we need to match each graph with the corresponding equation. Okay, so there's 2 graphs and 4 equations. So we need to figure out who goes with what. Did you get it? Okay, so this graph, if we look, it's going down, and then it starts to repeat here. So we need to figure out, is it 1, 2, 3, or 4? Okay, so this one means the amp is going to 4. Does any of these go as high as 4? Well, these are going higher than 4, right? They're going to 5. But if you think this is also a vertical translation, meaning that it's going up 1. Okay, so in our first equation, if our amp is 4, but we moved up 1, that means it should be going as high as 5, and then as low as 1. So it could be this one or this one, right? Then we just have to decide if it's a sine graph or, right? So in this situation, if we were up here, like for cos ones, you should be starting at your period length, right? And then moving up. So this one looks like it moved up 1, right? And it was a sine graph, and it moved up, and then it came down, and then it started right there again. So that looks more like this one. Okay, and let's just check the period length on this. This has no number in between there, so the period length should be 2 pi or 360, right? So when I drew this cycle, did it end at 360? Yeah. So 1 should be graph 2. What's that? Oh. Hold on a second. Okay, of course all my writing, as I pressed pause, disappeared, but we'll go through this again. We have to consider that these are shifted left or right also, right? So we know we're talking about graph. Let's talk about graph 1 for the moment, okay? So we know the period length, so it's going here, and then it starts to repeat again. Up, right there. And this one is right about there. Okay, so graph 1 looks like it goes as high as 5 and as low as 3, right? So the amplitude should be 4 in there. Because if it's going as high as 5 and as low as 3, if you go 5 plus 3, because that's the max and the min, and you divide it by 2, you get 4 now. Okay, and so that must mean that since it's going as high as 5 and as low as 3, they shifted up 1. Okay, then we need to look at the period length. So, okay, let's look at the ones that have this one, and this one have the amp of 4, right? That kind of eliminates this one right there, because it has the amp of 5. Okay, so we're down to those ones. So then the period length for this first one should be 360 divided by 1, which should be 2 pi is 360, right? Okay, and then these ones have a period length of 360 divided by 3, which is 120. And then it's either moving to the right 90 degrees or it's moving to the right 60 degrees is what they're saying. Okay, so if this is 90, all these ticks are 30, 60, 90. So that means if it moved 90 to the right, if we wanted to move it back, then we'd have to move each piece back 3 ticks. 1, 2, 3. So our original picture would have been here, like that. Oops, did that already. So it would have looked like this, right? So when you move it back, that must mean it's a cos one. So that's why they pick it as this one here. For, sorry, this one here. For graph 3 that we're talking about is this one. And this one we had said was 1, right? Because it had moved, what did we say? 90 back. Whereas this one moves 60 back. The other thing you can do is enter these on the graphing calculator and then see what they look like also, right?